There are three methods to charge a body, namely charging by friction, conduction, and induction. Let us first look at charging a body by friction. When two uncharged or neutral objects made of different materials, say a glass rod and a silk cloth, are rubbed against each other, both objects get electrified due to a transfer of charges. This process is called charging by friction. When rubbed, the glass rod loses a few electrons to the silk cloth. This deficit of electrons on the glass rod makes it positively charged, and the excess of electrons makes the silk cloth negatively charged. In this method, there is a transfer of electrons from one body to another. The material that gains electrons is negatively charged, and the one that loses electrons is positively charged. In this case, silk is negatively charged and glass rod is positively charged. Let us now look at how a body can be charged by conduction. If we momentarily touch the positively charged glass rod to an uncharged pith ball, the pith ball becomes positively charged too. This process of charging by bringing a charged body in contact with a neutral body is called charging by conduction. In this case, some electrons are transferred from the pith ball to the glass, and thus the glass becomes less positively charged by gaining the electrons. We observe that both bodies involved in this method of charging by conduction acquire the same type of charge once the process is complete. Let us illustrate this by a numerical example. Let us assume that initially glass has a deficit, Ng, of 200 electrons. Using the quantization of charge principle, that is, Q is equal to Ne, we see that the charge on the glass is Qg equal to plus 200 E. Now, when this glass rod was in momentary contact with the pith ball, let us assume that because of the electrostatic attraction, a few electrons, say Npg equal to 50, are transferred from the pith ball to the glass rod. Now, the pith ball has the deficit Np of 50 electrons, which implies that the charge on the pith ball Qp is equal to plus 50 E. Similarly, the glass now has a charge of plus 200 E minus 50 E, where minus 50 E is the charge due to the 50 electrons gained by the glass. Therefore, the effective charge on the glass is plus 150 E. Hence, it has become less positively charged compared to its original state. We can also charge a body without contact, as in the first two methods. The third method to charge a body is induction. When a charged object, A, is placed near an uncharged object, B, object A induces an unlike charge on the near side of B and a like charge on its far side. In this case, the charges inside B are only polarized and no transfer of charges takes place. This process of polarization of the charge on an uncharged body, when a charged body is held close to it, is called induction of charge. For example, bringing a negatively charged rod near a neutral metal sphere will induce a positive charge on the near surface of the metal sphere and a negative charge on the far side. When the negatively charged rod is brought near the metal sphere, a few free electrons in the metal sphere move away to the far side of the metal sphere due to repulsion, leaving a positive charge on the near side. This charge is temporary. That is, if we move the glass rod away, the sphere returns to its original uncharged state. When the negatively charged rod is held close to the metal sphere, the charges in it are polarized due to induction. Now, if we earth the far side of the metal sphere using a conducting wire, the electrons on the far side of the metal sphere flow into the earth. However, the positive charges on the near side of the metal sphere are held at rest by the negatively charged rod. Now, if we take away the glass rod from the sphere, the positive charge on the metal sphere distributes uniformly across the sphere. In this way, we can retain the charge on the metal sphere. In the method of charging by induction, we observe that the induced charge is always equal to the inducing charge for a conductor. Now, we keep two metal spheres, A and B, supported on insulated stands, in contact with each other. When we bring a positively charged glass rod near sphere A, negative charges accumulate on its near side, and positive charges accumulate on the far side of sphere B, according to the principles of attraction and repulsion respectively. Now, separate the spheres by a very small distance, keeping the charged glass rod near them. There will be a force of attraction between A and B. Then, if we move away the glass rod, sphere A will retain the negative charge and sphere B will retain the positive charge. We observe that the excess charge on the metal spheres distributes uniformly later.